5 mangoes and 2 oranges cost 500 UGX, while 6 mangoes and 4 oranges cost 640 UGX. We are told to determine the cost of each fruit using the matrix inverse method. So for you to use matrix inverse method, you need to come up with equations. Once you have your equations, change them into matrix form. Then you go ahead and solve those equations using the inverse method. So let's summarize what we are given. These are 5 mangoes and 2 oranges. So you're going to say that since you always look at the required part, you are interested to know what is the cost of each fruit. Okay? What is the cost of each fruit? So it means that I'm going to define my variable. This is question 1. Part A. So I'm going to say you can use X, let X be mango. Okay. That is our, yeah, let X be the cost of each mango, then and Y be the orange. Once you define, then you can form the equation. You are told that 5 mangoes, so it is 5 times X. 5 times X, that is 5X, and plus 2 oranges. When you aggregate, when you sum up, you must get the cost of 5. We are going to say that this is what? So it will be 5x plus 5x plus what? Plus 2 oranges, that is 2y, is equal to 500. That is your equation 1. That is your equation 1. Then equation 2, we are told that 6 mangoes and 4 oranges cost 640. So it will be 6y plus 6y four y, and that will be equal to 640. And this will be your equation 2. Once you've colleagues, just a minute, I first refresh. Looks like network is not stable. Okay. I confirm whether you can hear me. Someone
Yes,
confirm?
yeah.
Okay. So we have 2 equations which we must solve them using the inverse matrix method. So once you have these 2 equations, you must come up with, or you form these ones into matrix form. Then we can go ahead and look for the value of X and Y. But you're going to select the first step, you are going to select let A equal to this matrix, this first one. Let A equal to this. Okay. Then from this, you're going to look for the determinant of A. Because when you're using inverse, it means that you need a determinant. You cannot use inverse matrix method when you don't have determinant of a matrix. So you're going to say that determinant of A determinant of A is equal to, do you recall how we get the determinant? You multiply the major diagonal, then you subtract the minor diagonals. So these are 5 and 4 are on the major diagonal. So you get 5 times 4. Then you subtract the figures on the minor diagonal. That is 6 and 2. So you get 6 times 2. What do you get? This is 20 minus 12. What do you get?
8.
It will be 8. So that is your determinant. That is your determinant. Once you have your determinant, then what will be the inverse of matrix A? What is the inverse of matrix A? Inverse of matrix A is equal to, that is inverse of matrix of A. For factors of A, we have, do you recall how we get cofactors of A? Do you recall?
We interchange them.
Interchange the figures on the major diagonal.
We interchange the figures on the major diagonal. Then,
and change the signs on the minor diagonal.
When you're getting cofactors, you interchange these figures on the major diagonal. Interchanging means that where you have 5 put 4, then where you have 4 put 5, you are interchanging the figures on the major diagonal. Then the figures on the minor diagonal, you change the sign. Change the sign on these figures. So here it's negative. This one will also be negative. That is your cofactors of this is a cofactor of A. Okay, so once you have this, you can substitute in your formula. So my inverse of A, my inverse of A will be equal to, 1 over determinant. Already we have our determinant. That is the 1 over 8. Then we multiply by the cofactors of A. These are our cofactors of A. What will you get? It will be equal to, over 8 times 4. What do you get? Here, what do you get? This is 0.5. Then here?
Negative 0.25.
Negative 0.25. Then here?
Negative 0.75.
Negative 0.5.
0.75.
Yeah.
Yes.
7.
Here?
0.625.
0.625. 3 decimal points are enough, okay?
Okay.
Okay. So that is our inverse of A. That is our inverse of A. That is our inverse of A. Once you have inverse of A, multiply that inverse both sides. You have this, you have this. This is what we have. So multiply that inverse both sides. You multiply it on left side and also multiply it on the what? On your right side. So you will get this. You will get this. Then multiply by all this, what you have on the left. Then all this will be equal to, still you bring your inverse, because we are multiplying inverse both sides. So you bring that inverse. Then times what? Times this. You are multiplying your inverse both sides. Okay. So what do you get? Remember the rules of matrix. We multiply We multiply row by column. This is your row, 0.5 and negative 0.25. That is your row. So multiply that row with a column. That is 5 and 6. That 5 and 6 is in a column form. So what will you get? What will you get? I'm waiting to hear from you. This will be like 0.5. This will be like 0.5 times 0.5 times 5. What do you get?
2.5.
2.5. You get 2.5. Then add negative 0.25 times 6. What do you get?
Negative 1.5.
Negative 1.5. Okay. Then here, what do you get? The next row by column. Here, let's first focus on this. Still, it will be row by column. 0.5 times 2. What do you get? This figure
1
times 2. You get 1, okay? So it will be 1 plus what? Negative 0.25 times.
Negative 1.
What do you get? Negative. It will be the figure here. It will be a row. This is your row, negative 0.7 and 0.625. So if you get negative 0.75 times 5, what do you get?
Negative
0.5. You get negative 3.75. Then plus 0.625 times 6. What do you get?
3.75.
You get 3.75.
Negative 1.5.
Okay, then here, what are we going to get?
Negative 1.5.
It is row by column. This is your row times this column. Plus, if you get this figure, times 4, what do you get?
2.5.
That is 2.5. Okay, then you will bring your x and y here. Then this one will be equal to, still we do the same here. We do the same here. Row by column. Row by
250.
column. So it will be here what? What will you get here? It is 0.5 times 500.
250.
That is 250. Then plus negative 0.25 times 640.
Negative 100.
Negative 100. Okay, negative 100.
No, not
negative
100.
160.
160. Okay, then here what do we get? Negative 0.75 times 500.
Negative 375.
375. Then plus is positive 0.625 times 600.
400.
400.
You get 400. Perfect. So once you have this, then do summation and get the final figure.
1, 0.
Wait a minute. Wait a minute. Wait. Here you get 1. Then here.
0.
0. Then here.
1. 0.
This is
0, 1.
Yeah.
Then 1.
1. Remember, what are we doing? We are getting 2.5 plus negative 1.5 to get this one. Here we are getting 1 plus negative 1. Then here negative 3.75 plus 3.75, you get 0. Then here, just that I forgot to put bracket. Once your colleagues, take note that when you're doing this and you don't get this kind of matrix at the end, you know that you're wrong. Know that you're wrong. Know that you're wrong. So this one will be equal to,
410 and 25.
This will be
9.
400. The first one is what? 250.
90.
That is 90. Okay. Then in the next one is what? Negative 375 plus 400.
25.
Please use your calculator very well. These things are going to be easy, but if you don't use your calculator, you'll fail. Okay,
25.
so finally, you're getting 1 times x, that is x, that will be your x is equal to, actually your x will be equal to 90. Then your y will be equal to what? Y will be equal to 25.
25.
That is the final. That is your x and that is your x and y. And if you substitute these values in any of your equations here, you must get, if you substitute x here and y here, you must get 500 if you want to prove. But in an exam, you don't need to waste time proving. Okay? But if you can, you prove yourself to see that you're correct. So, colleagues, that's all. You will say, therefore, the cost of each mango, each mango is UGX 90, and the cost of each orange is what? Is UGX 25. Okay? Are we okay?
Yes.
So that is part A. That is part A. Next. Next part, what are they telling us? Okay, part B. Part B, required part, they are telling us we construct a decision tree and use it to determine the expected monetary value for each area. Okay, so here we need to construct the decision. We need to construct the decision tree. We need to construct the decision tree. Okay. Which screen are you seeing?
The question.
Just a more minute. Just a minute. What about now? What are you seeing?
Solution.
Okay. Okay. So we are constructing a decision tree. Remember the rules. The rules you must follow when you're constructing a decision tree. Decision tree. Rules. Each each decision alternative must start from what?
From a box.
Then each other books may call it a different way, but for now let's stick to a box. Each state of nature must start from a circle.
A circle.
Circle.
Those are rules you must follow when you're constructing the decision tree. These are the rules. Okay, so it means that you need to determine from your case study, you need to know what is your decision alternative, what is your state of nature. Decision alternative, you have control. But with state of nature, you have no control. And with state of nature, each is assigned to a probability. Probabilities can be given in decimal points or in percentages. Okay, for you to differentiate these two. Okay, so what are we told to do, or what are we given? This is Web3 Limited, a consulting company in general trade. Web3 Limited, a consulting company in general trade, decided to engage Nange Wendi Consults for consultancy services in the real estate sector. The company wanted to buy land in the different parts of the country with a view of optimizing their return on the investment. The land was either elevated, tableland, or inclined. Nange Wendi Consults generated the following information with different payoffs in the USD dollars. Okay, you have alternatives. These are areas, Ruchiga, this is Kabare. Ruchiga, Kabare, and the Kisoro. You have states of nature, elevated, tableland, and the inclined. Now, you don't have the percentage for inclined, but you can get. The remaining percentage is what? The remaining percentage, you will know it when we are doing, okay? But of course, the percentage must be 100%. The percentage must be 100%.
20.
So if you add this and this and you don't get 100, you know that the remaining percentage will be percentage for inclined. Now, another issue is that if you're in an exam and you realize that you're not given percentages, what can you do with states of nature? Assume that the percentage is equal. You have 3 states of nature, so each is 1 to 1 to 1. So each will be 1 out of 3, 1 out of 3, 1 out of 3. That is in a situation where you are not given the percentages or the probabilities. Okay? So we have alternatives, we have states of nature. Let's construct, and these figures are in dollars, So let's construct our decision tree. So we have 3 states of nature. Sorry, we have 3 decision alternatives. Ruchiga, Kabare, and the Thoro. Okay. So I am going to make my my box here. Here I'm going to put the first one is what? Is the Kisoro. Is it Kisoro or Ruchiga? Ruchiga. Colleagues, Ruchiga is a district. I don't, some of you know that Ruchiga is just a language. But we have a district called Ruchiga. That's where I come from. It's a good district. Then here we have what? The next one is
Kabare.
Ruchiga was separated from Kabare. Okay. Then here is
Kisoro.
Soro. Soro is after Kabare. Okay. Some of you needed to visit these districts. What? These are decision alternatives. These are decision alternatives. You will never find a probability on your decision alternative. Never. Never. So once you present your decision alternative, then go ahead. Remember, each decision alternative must be affected by the state of nature. So if you have 3 states of nature, all those 3 states of nature must affect your decision alternative. Okay, how many states of nature do we have in the question?
3.
We have 3. So it means that I must present my states of nature. But remember, we say that each state of nature must start from what? From a circle.
A cycle.
Okay. The next state of nature is what? The next state of nature is
Tableland.
tableland. Okay. That is our next state of nature. And the corresponding probability is
0.15.
0.15. So finally, once you have your, this is your decision tree. This is your decision tree. But remember, you must have the outcome. You must have the outcome. What we call payoff. Payoff means net gain or net loss. The final outcome. You are in the business. Of course, maybe you expect the outcome at the end, you expect to make profit, or it could be at the end, you can make losses, depending on your investment and the nature of the nature where you're operating. So what is the outcome? You here, you have Ruchiga and the state of nature is elevated. What is the outcome there? From the question. From the question,
40,000.
you have 40,000. Okay, these are your payoffs. So I can create a column. I can create a column here. I can create a column for payoff, my payoffs. I can create a column for my payoffs. So here you will create a column for payoffs and just do it at once. Okay, so from here, our probabilities, this is 0.65. This is joint probability. We just have one probability on each branch. On each branch, we just have one probability. This is okay. What is the payoff for elevated? That is 40. Is it 40?
Yes.
40,000. Then the next one here is what? Here it's cover. No, still Ruchiga. Still we are still handling Ruchiga. Tabled. That is 3. That is 32. Yeah.
Yes.
That is 2. Then still Ruchiga, where you have
5.
inclined. That is 5,000. Okay. Then for Kabare, the first one is what? 20,000. Then next 15,000. Then next
Negative 12.
negative 12. Okay. Then Kisoro.
35.
Yeah, you have 35,000.
Yeah.
Then next
60.
6,000.
60.
Then negative.
The upper one is 60.
Do we have a wrong figure?
Yeah.
Where?
Before negative height is 60.
Where exactly?
Next row.
Sorrow, the 0.15.
It's 60,000. Eh?
Mm.
Okay.
And on Kavale, the probability you
And the
had.
cover where?
No. You corrected the probability. It's okay.
65.
So 6,
Here
5.
it's 5. Okay.
Yes.
Do we have any other error? This is 0.65. This is 0.15. Are you hearing background noise?
No.
Okay. So expected payoff, you simply get the probability times the payoff. Just okay, here what do you get?
800.
1,000.
Okay, that is our expected payoff. Colleagues, this is your decision tree. Just that they need you to determine the expected monetary value. I'm still competing with noise here. Just give me just like 2 minutes. Eh? Okay, so how do we get expected monetary value? How do we get expected monetary value? Using the decision tree. Using the decision tree. Already you have your expected payoffs. These are your expected payoffs. You need expected monetary value for each alternative. You need expected monetary value for Ruchiga. Ruchiga need expected monetary value for Kabare. You need expected monetary value for Soro. Okay. So how do you get expected monetary value? You have the branch. This is your branch for Ruchiga. Simply move and add all the values you have. This is Ruchiga, or add all expected values you have. This is Ruchiga, so we add these values. We add these values. You can call this one. Sorry. You can call this one expected monetary value. Get this plus this plus this. That is your expected monetary value when it comes to Ruchiga. Then Kabare, what is expected monetary value? Expected monetary value will be 13,000
5,950.
plus
5,950.
2,000 plus negative that. That's what you have?
Yes.
12,850, yes.
Okay. Then for Xoro, expected monetary value, it will be this plus this plus this. And that's all. That's all. When you're in an exam, that's what you're supposed to do. That's what you're supposed to do. Because examiner wants to see everything on the decision tree. Okay? Remember this area, you can be asked to use the payoff table, or you use the decision tree. When it comes to these numbers, you can use the payoff table, or you use the decision tree to come up with expected monetary value. Perfect. So when you're using payoff table, I believe, I don't know whether, when you're using payoff table, you just convert your values. You just convert your payoffs. These are payoffs. You convert these payoffs into expected payoffs by multiplying the corresponding probability. So you change all these values by multiplying the corresponding probability to get the expected payoff. Once you have the expected payoff, then you create another column here, another column for expected. You change these ones into expected payoff. So you will be getting 40,000 times 0.65. You get 32,000 times 0.15, like that. After changing, you create another column for expected monetary value, expected monetary value. Now that you add all the expected monetary, all the expected payoffs for Chiga, add expected payoffs for Kabare, add expected payoffs for Soro. You'll be in a position to get expected monetary value for each alternative. I believe when you meet that question, you don't need it. When you meet that question, I believe you will be in a position to pass. In a situation where they have not said that you use decision tree, please you use the payoff table. It is easy. Don't give yourself a hard burden using the decision tree. Use the payoff table, but just convert these ones into expected payoffs by multiplying the corresponding probability. Then create the column for expected monetary value. Okay? Any question? Because I'm done with Roman 1. Any question with the payoff table or using decision tree?
No.
Okay. So Roman 2, they are telling us that we determine the expected value of perfect information and comment whether this is Nange Wendy should be employed if she charges 5,500 US dollar for her work. So in a situation where you meet this kind of question, you must first get the expected value of perfect information. How do we get expected value of perfect information? So expected monetary value. That is EMV, expected monetary EMV, expected monetary value of perfect information, information will be equal to what? We get expected monetary value with perfect information, then we subtract the highest or the maximum. We subtract the maximum expected monetary value. That is our formula. This stands for expected monetary value with perfect information. Expected monetary value with perfect information. So the question is, how do you get expected monetary value with perfect information is equal to what? How do we get this? How do we get this? I told you base on what? Based on the state of nature. And for each state of nature, for each state of nature, choose the highest expected payoff. For each state of nature, choose the highest. How many states of nature do you have in this question?
3.
We have the first one is we have the first one is elevated. Then the next one is tableland. Then the next one is what? Inclined. For each state of nature, choose the highest. Choose the highest. So here you have the expected payoff. Expected payoff. Choose the highest.
26.
So you have elevated. This is elevated. Okay, this is elevated. Where you have elevated, please mark where you have elevated. This is elevated. Choose the highest. This is elevated, elevated, elevated. Choose the highest expected payoff. What is the highest? From all the
26,000.
you have 26, you have 13,000,
48.
you have 22,750. So the highest is it 26?
Yes.
Yes.
Yeah.
That is 26. Okay. Then next, tableland. Do the same. This is tableland. This is tableland. This is tableland. Choose the highest. What is the highest? This is
4,800.
This is 2,000. This is 9,000. So the highest is 90,000. Is it?
Yes.
Then inclined. Inclined also compare all the figures to the highest. So here you have 1,000. Here you have negative. This is negative. Okay. Then also this is negative. So the highest is what? 1,000. 1,000.
1,000.
So finally, sum up to get your
36.
expected monetary value with perfect information. Sum up. You get this plus this plus this. And that is your expected value with perfect information. So next, do you have maximum? What is your maximum?
Yeah.
What is your maximum money? What is your maximum expected monetary value? What is your maximum?
2,800.
Remember, you have already your expected monetary value for each alternative. For each alternative, this is for Kaba, this is for Ruchiga, this is for Kabare, this is for Kisoro. Okay, so from these three expected monetary values, what is the maximum? What is the highest? The highest
31,800.
it's 31,800. Okay, so it is it's 31,8.
Abel, a minute.
Yes, please.
You said you get the highest values of each state of nature, right?
Yes.
When you, then why is 9,000 coming in and 1,000?
Okay, let me go back and we see for tableland and inclined. Okay.
Yes.
Let's observe tableland. The first figure is 4,800. That is the first figure. The next figure is 2,250.
Okay.
Then the next figure is 9,000. What is the highest?
Okay. 9,000.
Okay.
Yes.
Are we okay?
I've understood. Yes.
Yes.
So from your expected monetary values, perfect information and maximum expected monetary value, you can be in a position to get expected value of perfect information. Expected monetary value of perfect information will be equal to get your expected monetary value with perfect information, that is 36,000, then subtract the maximum expected monetary value, 31,800. What do you get? Get this minus this. And this figure is in USD dollars. So the question is,
How did you get the sorry, how
Yes,
did you get
please.
the 31,800?
This one.
Mm.
Okay. Remember, we are saying choose the maximum, choose the highest expected monetary value from your decision tree. From your decision tree, already you have the expected monetary value. This is the expected monetary value. This is the expected monetary value. This is the expected monetary value. Choose the highest, the maximum. Okay.
Okay.
Is it clear?
Yes, please.
Colleagues, you're here alone. You're here alone. Please, where you need clarification, you ask. In an exam, you will be alone. Don't feel shy to ask. Okay. Please, there you're finding it is the same question. Okay, so from the part, remember they said you comment whether Nanga Wendy should be employed if she charges 5,500 US dollars. Now, when you do the research on your own as a company, when you do the research without engaging any consultant or any specialist, this is the amount of money you're going to incur when you do your own research as a company. This is the overall amount of money you're going to incur. But if you decide to engage the specialist like Nange Wendy Consult, you will incur 5,500 US dollars. This is the cost you're going to incur if you engage the Nange Wendy Consult. So the question is, should we go ahead and engage Nange Wendy Consult, or we do our own research?
No.
We do our own.
We do our own research.
So we can do our own research. So you will comment and say that Nange Wendy should not be employed. That should be your comment. Nange Wendy should not be employed because her cost is expensive or is higher compared to the cost of the company doing its own research. Let me see. Let me just write. Comment. Nange Wendy. Nange Wendy Consult not be employed. You just write something using your own language, own words. Okay. You can use your own words. Just you need to know that this expected monetary value of perfect information, that is the cost the company is likely to incur if they decided to do the research on their own. But this one, it's the cost they are going to incur if they hire a specialist like Nange Wendy Consult. Okay, any question? Because we are done with that. We are done with that. We are done with that. Okay. Is it very hard?
Yes, practice.
You have like only 4 days.
Yeah.
Okay, but you try to understand.
Yes.
Okay, Patsy. In a sample of 600 students, 0.1% have access to the student's loan. Determine the probability that exactly 2 students will access, Determine the probability that exactly 2 students will have access to the student's loans, given that the loan distribution follows, a Poisson distribution. Okay, which formula do we normally follow when we are answering this? This is the, I'm done
Poisson?
with the, I'm done with the, this is done. Done. Here we are handling part C. We are given the number of sample. Number of sample is what? From the first one. Number of sample is 600.
600.
That is the number of sample, the sample size. Sample size. Okay. What else are we given? The probability of students accessing the loan. 0.6% have access to the student's loan. Always look at the required part. Is the required part taking you to the students who have access to the loan, or you're talking about the students who have no access to the loan? Please always look at the required part. This is the probability that exactly 2 students will have access to what? Will have access to students' loan. So you can define and say that let P be the probability of students accessing the student's loan. So let P be the probability of a student accessing the student's loan. Okay. So it means that your P will be equal to what? 0. What probability? What will that probability? 1%. That is 1%. 0.1%. 0.1%, which is the same as what?
0.001.
Now, people who use their heads, sometimes you
No,
get
no.
issue. Now, if you use the calculator, still you get 1 times 10 power negative 3. You fail to know how to read that value on your calculator. So it is 0.001 should come on the third place. So that will
001.
001. Is it? Okay. So what so from this, colleagues, this is not binomial. You're using
Poisson.
Poisson.
Using Poisson distribution, probability distribution. The probability of X is equal to, let's say, R is equal to, what is the formula? How do we get this? In your
Negative.
E power negative lambda.
We
divided by
can
x
find it. Is the
factorial.
mean?
okay, lambda power what? It is lambda power what?
Power x.
Power R. You're using, if you put here R, it is power R.
Power
Then everything divided by what?
R
Everything
factorial.
divided by
Oh, X.
R factorial. So do we
R.
have mean?
Or X.
Do we have lambda? We can
No.
get. We can get. Our mean is the sample size times the probability of success, which will be equal to 600 times the 0.001. What do you get?
0.6.
0.6.
0.6. What is our R? Which probability? We are looking at the probability of X is equal to 2. Exactly 2.
Yes.
So if they say exactly 2, you use equal signs. So we need the probability of X is equal to 2. It will be equal to
2.
Probability of X is equal to 0.
Now we go This is exactly 2.
Exactly 2, not less than 2.
Dealing with inequality greater or less. No. Here we are dealing with probability of X is equal to 2. So where there is
2.
R, put 2. Where there is
Put
lambda,
2.
put your mean. Okay. So you will copy. This is your formula, sub 0.6. This is power 2. Finally, using your calculator, can you manage?
Yes.
In your paper, you will find you have, let me open one of the past papers. You will find that obviously you have these formulas, but I normally tell you, sometimes formulas are not, the formula you want is not given. And you can't ask the formula in an exam. You can't say that here the formula is not given in an exam. You can't say that here the formula is not given. What can I do? Can I ask my neighbor? Right? That one will not be allowed. So let me try to, this is what? 50 questions. December 2024.
0.0988.
So in an exam, you will not be having that chance to ask your neighbor. So this was the last paper.
It was there. But in the briefing, they told us that all the required formulas in that paper are given.
Now,
Not all.
not all, not all, not all, not all. Some formulas you'll find that some will be there, but some will not be there. If you get chance, you'll find that all formulas are given, but it's not a must. Try to understand some of the formula. So it's given here when you look at. Just that for us we have used the R, but it's given. It's given here. It's given. Okay. You will move out saying that it's a surgery. Yeah. So what do you get?
0.0988.
Get your calculator. I understand that some of you don't know how to use your calculator. So you click shift, then click on that button where you have IN, that is IN. If you click shift, then click shift, then that button where you have RIN, you will be in position to see E appearing on your calculator. Please, when you use shift, don't again, when you use shift and see E, don't again put power. Already that E is power. Simply write negative 0.6. Shift, then click on that RIN button, then write negative 0.6 times, sometimes I say open bracket, 0.6 close bracket power 2 equal signs. Then divide by 2 factorial 2, write 2, then click shift, then click where you see x power negative 1, depending on the calculator you're using. Okay? So if I click this, okay. The answer is what? 0. 0 point what?
0988.
0.09.
098.
4 decimal points. 4 or 3 probabilities. 4 decimal points or 3.
88.
Let's use 3 decimal points. 0.099.
88. Okay, 9.
Okay. Or if you want to use 4 decimal points, it will be 0.988. All of you, are you getting this? All of you, are you
Yes.
getting? Okay. Please, if you're not getting this, be open. Be open. Be open and say here. So, if they say you get the probability of x greater or equal to 2, what do you do? If they say you get the probability of at least
Mm.
2 students, the probability of at least 2 students accessing students' loan, what do you do?
You get probability
Of
of
less than 2
up to 1.
up to 0.
Screen, are you seeing?
Yes. Yes.
Solution screen.
So what do you do if they say probability of at least
Probability
2
of
students
0 plus
accessing
probability of
the
1.
loan?
And then you'll get 1 minus that summation.
You repeat?
You get the probability of less than 2, which is 0 and 1, and then you add them. After you subtract them off from 1, which is the total probability.
So I get 1 minus what?
Probability of x less than 2. Less than 2.
X less. I put less or equal to, or I just put less?
Less.
Please, colleagues, I want you to understand this thing. Don't mess up in an exam. If this figure is inclusive, remember, if this figure is inclusive, it's like you're getting probability of x is equal to 2 because 2 is inclusive. Then plus probability of x is equal to 3 plus the probability of x is equal to 4 up to infinity, because you don't know how many up to actually 600, but this is wrong way. So shortcut, it's to get, you know that the total probability is always 1. So you get 1 minus figures that are below, below 2. Because here already you have 2. So you need figures that are below 2. So it will be probability of x less than what? 2. whereby probability of x less than 2 is equal to the values below 2. Values below 2, you have 0, 1, it's always round 1. So it will be equal to 0, because you may find that there is no students who is going to access their own. Then plus the probability of x is equal to 1. Please don't make a mistake. It all depends on what you have, where you have started from. If they say probability of x greater than 2, what do you do?
Greater than 2.
Here there is
You-
no 2. So what do you do here?
You get the probability of
The
1 minus probability
So here it's like you're
Probability.
starting from
From
3.
2.
So it will be like probability of x is equal to 3
Mm.
plus the probability of x is equal to what? 4
4.
up to infinity. Up to infinity. So the shortcut will be, it will be to get 1 minus the probability of what? X.
Less
So it means that 2 is
less or equal to
inclusive.
2.
Values below 3. Values below 3. So it will be
Less or
probability of
equal to 3. 2.
probability. This is less or equal to 2. Because 2 will be inclusive. 2 is below 3. 2 is
Yes.
below
Yeah.
3. So also don't make a mistake. Where probability of this one will be equal to what? Probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. I believe
Yeah.
you can see the difference. It all depends on where you have started from. Here, if you start from 2, it means that if you use the shortcut, that 2 will not be inclusive. Okay, so we are done with that question. We are done. And where you say that if a question is like this, if a question is like, let's say, get the probability of at least 2. The question is saying that at least 2 students accessing the loan. So it means that you will need to get the probability of x is equal to 0. You get that probability, then also get the probability of x is equal to 1. You substitute in your formula. This is your formula. So you substitute. This is your formula. You substitute. Where you have r, you put in now. Where you have r, you put here, you put 0. Here you also put 0. Then for this one, x is equal to 1. Where you have r or where you have x, you put 1. Okay. Once you get these values, you'll be in a position. You'll be in a position to get the answer. I want to pick at random. Probability of, you first get the probability of x less than 2 will be equal to, you add
0.8781.
then plus 0.3293. What do you get?
0.8781.
87.
81.
So finally your probability of. So next question, part D. Part D. A manufacturer has 3 machine operators. The first and most experienced operator A produces 6% defective items. whereas B and C produces 8% and 12% defective items. Are you in a position to hear me?
Yes.
Okay. Operator A and B are on the job for
What am I
are
supposed
on,
to do?
are on the job for 5 and
Yeah, that's the problem. Because I'm supposed to, she needs the, call me, I thought she was coming tomorrow. Remember, even she said she's not going to be around tomorrow. So she decided to come.
Okay. That's the question. Operator A and B are on the job for 45% and 30% of the work time. Remember, there is a remaining percentage. Okay. Determine the probability that determine the probability that an item was produced by operator C, given that it was defective. When you see this kind of question, think about conditional probability. Think about conditional probability, the Bayes theorem. You can answer this question using two methods. Either you use the probability decision tree or you use the Bayes theorem. And what are the steps that we normally follow? What are the steps that we normally follow? What are the steps that we normally follow? Steps 1, define events. Define events. For example, like for this case, I can say that let E1, I can use E1, let E1 be event that the item is defective no. Let's not talk about it. Let E1 be the event that the item was produced. Yeah, was produced by operator A. Okay. Then you say let E2. Okay. Then step number 2. Determine the probabilities. Determine the probabilities. The probabilities of events. You have defined your events. So what are the corresponding probabilities for each event? So the probability of E1 is what? From the question. What is the probability of E1 from the question? What is the probability that the item was produced by operator A?
45%.
Operator A and operator B are on the job for 45% and this is 45%, 30%. Okay, so this will be
25%.
Because here we are, this one 6%, 8%, 12% talks about defective. At this point, you're not talking about defective. You're just looking at your operators. So here the first one will be 0. What? 0.5. This will be 0 point what? 0 0.4. Is it 45?
Yes.
Then the next probability. The next
0.30.
probability will be what? The probability of E2 will be
0.3.
E2 will be 0 0.3.
Yes.
Okay. Then lastly,
0.25.
0.25. The remaining percentage. Okay. Those are your probabilities. Then step number 3. Step number 3. You determine the conditional probabilities. And now the conditional probabilities, we are talking about the defective, okay? The defective items. So what is the probability? Maybe you can define, you can say let also here, your event, let also let X be the event, that the item is defective. Now, when you're defining X, always look at the required part. Always look at the condition given. Always look at the condition given. Obviously, here the condition given is talking about the defective, okay? Given that it was defective. So that is the condition given. If they say given that it was not defective, then you define X to be an event that an item was not defective. Okay? Don't always rush. So from this, we are going to say that the probability, our conditional probabilities will be the probability of X, the defective item, given that it was produced by the first operator, given that it was produced by the first operator. Okay. And here, what is that probability? I believe we have those probabilities in the question. The first and the most experienced operator produces 6% defective items. So here you have a defective item that was produced by operator A, 0.06. That is 6%. So this will be 6%, which is the same as 0.006. Then next, it's a defective item given that it was produced by operator B. What is that percentage? What is that percentage? The percentage is 8%. 8%, which is the same as 0.006. Next. This is 2. This is 3. Even here it's 3. What do you get here? This one, it was given as what? This was given as 12%. And this is 0.12. Colleagues, are you following?
Yes.
Okay. So from this step number 4. Step number 4. Step number 4. You calculate the total probability of defective items using the law of total probability. Because we want to use the conditional probability, we want to use the conditional probability that by your theorem. Then we need this. What is this total probability of defective items? The total probability, that is probability of X, is equal to what? The law, using the law of total probability, when you're getting the probability of X, you simply get the probability of, what was the first one? The probability of E1. You simply multiply the probability of E1 times the corresponding conditional probability here. Then plus E2, then times its conditional probability. Let me say this, let me use dot. Then times its conditional probability is this. Then plus, bring this times its corresponding conditional probability. That's the law of total probability. You have everything, substitute. You have everything, simply substitute. The probability of E1 is 0.45 times 0.06 plus, open bracket, the next one is 0.3 times 0.08 plus 0.25 times what? 0.12. You can use your calculator direct to get the answer. I'm waiting. You use your calculator. Just open bracket the way you see here. Open bracket this time, this close bracket plus. Open bracket this time, close bracket plus. You can get the answer direct. What do you get?
0.081.
0.081. Okay. Last step. Step number 5. Apply Bayes theorem. Apply Bayes theorem. And what is the Bayes theorem rule? Do you remember? Basing on the required part, they are telling us we determine the probability that an item was produced by operator C, given that it was defective. So it will be the probability of operator C given that it was defective. From this, do you remember?
Yes.
How do you get this? Using Bayes theorem. It will be equal to, already we have probability of E3. E3, it was what? 0.25 times. What is this probability?
0.12.
0.12. Then over probability of X. Already we have the probability of X, which is 0.081. So finally, what do you get?
0.3703.
Okay, so finally the answer is
0.3703.
4.
0.370. And that
Four.
is the answer. That is the answer. Simple as that. Any question related to Bayes' theorem, any question related to conditional probability, apply these steps, you will not fail. You will not fail. Apply these steps, you will not fail. Okay? You will not fail. You can also use the probability decision. The probability. Do you want I talk about a decision tree? Probability decision tree? Or we just
Think
move
so.
on? Hmm?
Yes,
Please
you
talk
talk about it.
Which screen are you seeing? Probability.
Excel.
With probability decision tree, we are going to start with our operators. Probability is what? 40, is it 45? 0.4, 0.45. Isn't it? This is operator B. Operator B, the corresponding probability is 0.3. Then operator C, its corresponding probability is the remaining percentage, 0.25. Okay, then from here, all of them are going to produce. All of them are going to produce. So here, they are going to produce defective and non-defective. So I also bring here another circle. Do you know the reason why I'm putting a circle, not a box? Colleagues, do you recall the reason why I'm putting a circle, not a box? Eh? Do you recall the
Yeah.
reason? Because these are probabilities. Whenever you're going to present a probability, each probability must start. The defective is 6%. The defective probability of defective is 0.6%. The one related to A. Isn't it, colleagues? The one related to A. Then the one related to B. The one related to B defective is what?
0.08.
0.08. Then
And the first 0.06.
okay, let me change this. This is 0.06. Then this one defective. It's 0. What?
0.12.
0.12. So it means that the remaining percentage is that one of not defective. Okay. Okay. How can I write this? I put this. Okay. The probability of A not producing defective defective item. What is the probability of A not producing a defective item? What is the remaining percentage? 1 minus this.
0.9694.
This is 0.94. Then what about here? What is the probability of B not producing defective item? 1 minus 0.08. That is 0.9. Then what is the probability of C not producing defective item?
0.88.
0.88.
0.88. The outcome, if you multiply A producing defective. This will be this will be what? This will be 0.45 times 0.06. Then here it will be 0.45 times 0.94. Then here it will be 0.3 times 0.08. Then here it will be 0.3 times 0.92. Okay. Still have then here it is 0.25 times 0.12. Then here it is 0.25 times 0.88. Okay. So remember we want, okay, if you want to know the total, if you want to know the total probability, of a defective item, the probability of producing a defective item, you will see where you have defective. You will see where you have defective. Are we together? You will see where you have defective. This is where you have defective. Where you have defective, here you have defective. So if you add the outcome, this plus this plus this. Okay, 3 decimal points, I believe you get that. And I believe that's what we had, okay? Is it, colleagues?
Yeah.
I'm
Yes.
talking.
No.
Okay, then the question is, you get the probability of C producing defective, the probability of C, given that it is defective. What is the probability? What is the probability that an item was produced by operator C? This is operator C. This is operator C. An item produced by operator C, given that it was defective. Given that it was defective. So what is that probability? Are you seeing this? Are you seeing it?
Yeah.
That is the probability. The one that is we are going to get that, given that it was, we get this. Okay, we get this value. Because this is where you have, remember you are picking this, you're picking 0.3 from the overall total. This is your overall total defective. So you're going to get this 0.03 probability over the total defect. Where you are picking 0.3, the overall total is 0.3. So colleagues, the fact that we are looking for the probability of an item produced by operator C, given that it is defective, you simply pick this over the total defective probability, this one, over the total defective probability. So it will be this divided by this. That's what we have.
Yes.
Yes.
0.3704.
Okay. So if they ask you to use the probability tree, That's what you can do. How are you getting this? We are adding the defective ones. If they ask you the probability of if the question was talking about not defective item, then you focus on where you have not defective. Here. Yeah. Okay. If it was the probability of A given a defective, then you pick what? You pick where you have a defective here, this, but you're picking this from defective. So what is the total defective? Total defective is this one. So the answer would be this divided by this. Okay. So that's all. We are done with that. We are done with that. Next part E. The sales for the new cars. For the new cars X at BAF motors are randomly distributed and follow a normal distribution such that X follows this. Now, this is the binomial. This is the binomial. Required show that the sales for the new car can be approximated to a normal distributed. Okay. How do you handle that part E? Part E. How do you handle that? Part E. Very easy, but when you don't know, you don't know. See the problem with QT. These numbers are not all that complicated. These numbers are not all that complicated. The only issue is that in a situation where you don't know, you don't know. Can't gamble. And no marker for entries. So here you have, if you're given your data in this form, you're given data in this form. Remember, this is binomial. This is binomial. With binomial, just a minute, I pick it. Okay, are you in a position to hear me?
Yes.
Okay, which screen are you seeing?
Solutions.
Okay, so with binomial, please take note. This is like B follows, always know that B follows with binomial. B follows, because if you don't know what is this, then you get it wrong. B follows NP with binomial. Always know that N follows probability of success. With binomial. Okay, so what do we need? What do we need? We need to prove. We need to prove that this can as well be approximated to a normal distribution. Remember, normal distribution is normal distribution. With normal distribution, follows the normal distribution follows Do you remember follows mean? That is new. Follows new. Then this is new followed by the sigma. The sigma, that is variance. Variance square, variance, that is sigma squared, okay? Sigma squared. This is mean, this is variance. So you need to know, these things, You need to know these things. You can fill that the number is very easy. So it means that what is given here, colleagues, mute if you are not submitting. If you are not submitting, kindly mute. Okay. Remember what we have is x. This is a binomial. This is a binomial. Follows a binomial distribution such that this is a binomial. So it means that what you have here is n. What you have here is p. You get? So it means that from our scenario n is equal to what is that figure? Is that the whole figure? That is your n. Okay, that is your n. Then what is your p? P is the probability of success, which is what? 0.6, 0.65. Colleagues, are we together? Okay. So from this, we want to prove that indeed it follows a normal distribution. To prove that binomial follows normal distribution. We have two conditions. Two conditions must be satisfied. As a must, all these two conditions must be satisfied. One, NP must be greater or equal to 5. Must be greater or equal to 5. And NQ must also be greater or equal to 5. Take note. If you find that one of these two, let's say the first one or the second one, is below 5, then you cannot apply normal distribution. You cannot apply normal distribution. So let's prove that indeed binomial follows normal distribution. Let's see from this question. What is our NP? You get 1, 1, then your n, your sample size. This is your sample size. 1, 1, that is 1, 1 times 0.665. What do you get? 1, 1, 1, 1, 1 times 0.65. You get 722.15. That's what you have. Then
Yes.
what is your what is your NQ? Recall that Q is equal to 1 minus P, which is equal to 1 minus 0.65, and you get 0.35. So what is your NQ? NQ, you still get this. You get your N times 0.35. Do you have 3.888.685?
Yes.
So are all figures above 5?
80.
The question is, are all figures above 5?
Yeah.
Okay, all figures are above. Even if you find that the figure is 5, because the condition is any Q must be 5 or above. If you find that any Q or any P is below 5, you cannot apply a normal distribution. So conclusion, since any P and any Q are all above 5, since NP and NQ are all above 5, then it implies that you write this. It implies that it means that the cells for the nuka, for the nuka can be approximated to the normal distribution. And that's all. Okay. That's all for part A. So you need to recall this. If you find that one of these is below 5, then it implies that you cannot approximate to normal distribution. Then part B, or Roman 2. Roman 2, by approximation to a normal distribution, determine the probability that at least it means that figure is inclusive. At least 85 cars shall be sold by BAF Motors. So you will say Roman 2, you will say that here you need the probability of X is the probability of X, at least you use greater, is greater 85. Is it 85? It's 85, okay? So how do you get that probability using normal distribution? Using normal distribution, you have to standardize. Using normal distribution, you must standardize, okay? You must standardize, okay? So to standardize, do you recall the formula? Z is equal to what? If you have challenges with standard deviation, you can use just SD. If you have issues writing those signs, So it means that here you will standardize this. And because you're dealing with inclusive figures, okay, recall this. If you are dealing with the inclusive figures. If it is this, what do we say with greater sign? Do we subtract or we add? If it is greater, you subtract. If it's greater, subtract 0.5. If the sign is greater, if it is less, then okay, let me maybe have this to make it clear. Here you add. If it is less, here you add. Now, where are you adding? You subtract 0.5 from x. Then here you add 0.5 to x. So please recall these conditions. Okay. So here we have the probability of Remember, with these things we deal with exclusive figures. Okay? We deal with exclusive figures. So it means that this one I will say probability of I use greater, then I standardize following this formula. Okay. It's x, I'm standardizing 85. 85 is, but before we standardize, do we have mean and standard deviation? Because this is mean, x is the value you want to standardize. X is the value you want to standardize. So do you have mean? Do you have standard deviation? You can get mean. Mean or what we call mu is equal to what?
Mean we have NP.
Is equal to NP. And already we have that, I think, from here. Then what is standard deviation? What is standard deviation? It's square root of variance. Okay. Here you get square root of variance. So it will be square root of variance. Square root of variance. However, variance, which is equal to variance, is equal to what? NPQ. Variance is equal to NPQ. So you're taking square root of NPQ. So what will be the answer? Because you have everything. What is your N? What is, so yeah, it's like you're getting 722.5 times Q, which is 0.35. No, people be really following the session and will get confused. What was our N? 1, 1, 1, 1, 1 times what was our P? 0.65. What do you get on your calculator?
50.27.
50.62768.
That is the square root?
Yes.
Yes.
Let me first also do. Okay, that is 50.276. 277, okay? 277, okay. That is our standard deviation. So we can substitute from our standardization rule. We are going to say that the probability of x, sorry, z. Now, when you're standardizing, you don't again say x. It will be probability of z greater, greater than what?
X.
Greater than, we are trying to follow the formula x, which is 85, the one you want standardized, but because the one you want standardized has greater or equal to, you subtract. You subtract 0.5. Then minus what? Minus mean. What is our mean? 7222.15 over what is our standard deviation? 50.277. When you simplify, what do you get? This will be probability. This will be probability of z less negative what? You do everything on your calculator. You get open bracket 85 minus 0.5 minus 7222.15 close bracket over 50.277. What do you have?
Negative.
Pardon?
141.966.
141.967.
It's what?
Negative
Negative
141.967.
You have a different figure.
Right, let it again.
Have you divided by this?
Yes.
Yes.
85 minus 0.5 minus 722. How many twos?
There are 3.
3 twos.
I'm getting. What do you have negative?
Negative 141.
Negative 141.
Point 2 decimal points. Because you want to use the table.
0.97.
7.
0.97. Okay, so finally, you can use your table. Will be equal to, you're getting from here up to here. Remember, from here up to here, you get it from the table. From this to the separate line, you get it from the table. But from here to infinity is 0.5. So you're getting 0.5. Then add the probability of 0 less z less 141.7. Remember, when you're reading, you ignore negatives. Do we have that value from the table? Is it possible to trace that value from the table? This is Z. I don't know whether we have this Z. Let me open any past paper question. This is the QT. When I was typing, are you in position to hear me?
Yes.
Or you just confirm whether you can hear me?
Yeah, we can.
This figure is too much. Copied the wrong figure. Put here. Put here. Put here. Put 11. Yeah. You just put this because that's too much. Then here 111. Then put here 1. Sorry. So yeah, if you multiply 111 times 0.65, you get 72.
72.15.
Then here, what do you get? 111 times 0.5 is 38.85. Then this one was 72 point what? 15. Then here 72.15. Then if you put here, what is the standard deviation? Square root of 111 times 0.65.
Two point 39697.
Pardon? This is the answer?
Yes.
This is 0.02252.
25.
Okay, then next here, it will be 0.252. Then here, the final here. What do you get? 85 minus 0.5 minus 72.15 divided by 5.0252. So you get 2 point what? 2.4? 2.46. Okay. then this is 2.46. This is 2. This is 2.46.
Well, I'm getting 0.25.
Oh yeah, if you round off 0.2,
No, if I get 85 minus 0.5 minus 72.15.
minus 0.5 minus 72.15 over
No, that is divided by 5. Oh, I get it. It's okay.
5.00252.
Where are you getting your 5.025?
Here,
That one changed.
NPT.
All right.
remember we
It's
made
okay.
some changes, eh?
Yes.
Okay, so read this from the table. Here you don't need to bring a negative, so you read this from the table. I
So,
believe
but our 2.46 is positive.
this answer is positive, eh?
Yes.
The answer is positive. Okay, if the
Yeah.
answer is positive, then the diagram must change. Eh?
Yeah.
Yes.
Diagram must change. Since it is positive, I'm going to put this side. You want figures that are greater than this, so you shade this side. Eh? Okay. You shade this side. So if you shade that side, it means that this one will also change. This will be, because you want only the shaded part. So it will be 0.5. Because you know from this line to infinity, it's 0.5. So you get 0.5 minus the unshaded region. This one from here to this. Remember, you read value from the table basing on this from here to here. So it will be minus the probability of 0 less z less 2.46. What do you get from the table? What is that probability? What is the probability of 2.46?
0.4931.
246. This is z. This is z. So you look for 4. It is what?
0.4931.
246. 24 is here. Then look for column 6. Column 6 is here. The meeting point. So it is 4. Let me
931.
24 is here. Column 6 is here. Column 6. So it is 0.4931. 0.4931. What do you get? 0.5 minus
0.0069.
which is 0.0069. You see on the calculator, you get 0.9 times 10 power negative 3. So it means that this 6 must come on the in the third place. Okay. So colleague, that's all. That's all with that question.